So once again, welcome to class. Today, we are going to pick up from where we had stopped last time. And we had introduced set theory. We had introduced set theory. So that is what we're going to continue with today. Set theory. And because we discussed the theoretical framework, I gave you the notes on the same. For now, we will do questions. So, question one, or we just call it illustration. 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 Now, in the illustration, A is a set made up of 1, 2, 3, A, B, C, D. That is, those are members of A. B is a set made up of 1, 2, E, F. C is a set made up of 2, 3, C, E. You are given those sets. Then if you are told to give us A or B, that is what we call union of sets. A or B, that is the union of sets. Then I told you, you bring all the members who are in the two sets. So if we start with set A, we have 1, 2, 3, A, B, C, D. Then we bring the members of B. But the members of B are 1. Now 1 is already brought here, so you don't bring it again. Because we say no member should appear more than once. 2 is here, you don't bring it again. E is not yet brought, so you bring E. And then F is not yet there, you bring it there. So that is the union of sets. The next one, if you are told B or C, B or C, we say it again, you bring the members of B, 1, 2, E, F. And after that, you bring the members of C. 2 is already brought, 3 is not yet, so you bring 3. C not yet, so you bring it. E is already brought. So that is the union. If I were to tell you to give A and B, the intersection A and B, we are looking at members who are common in the two sets. So 1 is common in both, 2 is common in both, 3 is not, A is not, B is not, C is not, D is not. So the intersection is 1, 2. Similarly, if I tell you to give me A intersection C, A and C, A and C, A and C, then we are going to have the members who are common. A is not common. 2 is common. 2 is common. 3 is common. A is not common, B is not common, but C is common. And then D is common. No, it's not common. So we have those sets. If you are told to create the universal set, the universal of this one, it is the union of A or B or C. It is the union of A, B, or C. If you are told to get the universal, you are told to get the universal, you combine all of them. Sarah, good morning and welcome. Now, combining all of them, I will talk of 1, 2, 3, A, B, C, D. Those are members of A. Then we need to bring members of B. 1, 2, they are already brought. E, F, they are not brought, so we bring them here, E, F. When we come to C, we bring the members. 2 is brought, 3 is already there, C is already there, and E is already there. So this is the universal. That is the universal, which is the same as this A or B. Now, if I tell you to give me a complement, which I told you it can be written in many ways. These are ways of writing a complement. You can put an apostrophe there. You can write raised to power C. You can write A naught. Actually, you can also write A raised to power -1. All those are ways of writing the complement. All those are ways of writing the complement. So, I told you the complements of a set are members of the universal who are not members of that set. So when we are looking for the complement of A, we are looking for members of the universal who are not in A. Members of the universal who are not in A. So these ones, 1, 2, 3, A, B, C, D, those ones are in A, and they are members of the universal. So the members of the universal who are not in A are E and F. So A complement is just E and F. That's how you get the complements. Then, if you are told to give us B complements, those are members of the universal who are not members of B. So those members of the universal, 1 is in B, 2 is in B, but 3 is not in B, so 3 is the first one there. A is not in B, so it is also there. B is not there, so we bring it there. C is not there. D is not there. E is there, and F. So those are the complements of that set. If I were to give you B or C complement. B or C complement. B or C complement. B or C complement. So B or C complement, we want members of B or C who are not members of the universal. So because you already know B or C, now we want members of the universal who are not here. So 1 is there, 2 is there, 3 is also there, but A is not there. So A comes in there. B is not there, so it comes in. C is there. D is not. E is there, and F. Those are the complements. If I tell you A minus B, A minus B, those are members of A who are not in B. Members of A who are not in B. So 1 is in B also, 2 is in B also, but 3 is not. So I have 3. A is not. B is not. C is not. And D is also not. So those are members of A who are not in B. Similarly, if I want to get C not B, remember C not B is the other word for minus, or is the other way of writing minus. So we want members of C who are not in B, members of C who are not in B. So 2 is there. 3 is not there. So we put 3. C is not there. E is there. So that is all. So any question up to that point? Okay, so if we have no question, on your own in the past papers, you will let me look for a question. That is December 2014, question 5A. Question 5A, you will try that. And I told you, you need to submit your answers so that I can mark. If you are not able to submit and you still need the answers, and more so those who watch it online, you can buy my revision kit, which goes for just 1,000. It will help you in the revision. But for those who are already in my class, you just need to submit your answers. I will mark for free, but those who are not, you should buy the book, or if you are not able to submit or you are far, you can also get the book. So you try. This question is on the same. Let's now go to another question. Let us go to another question. In the past papers, get your past papers now. Get your past papers. And in your past papers, I want us to go to first of all, on your own, you also look at this one. We will also look at December 2022, question 1B. We shall look at that later on. Let me look for the question that we shall do together. The question that we shall do together is here in August 2022, question 5B. August 2022, question 5B. August 2022, question 5B. So in that question, I believe you have seen it. It is saying a survey of 850 residents of a certain town aimed at finding out the brand of vehicles owned produced the following results. So we have 316 who owned Nissan, those who owned Honda, those who owned Toyota, and so on. So in answering that question, the first thing is to come up with the Venn diagram. The first thing is to draw Venn diagram. That is always the first thing anytime you are in such here. Draw what we call Venn diagram. Now, Venn diagram is drawn in a smart way. Drawn in a smart way. Because there are three of them. That way. So this one is Nissan. This is Nissan. This is Honda. This is Toyota. This one we call it A, B, C, D, E, F, G, and H. That way. This is H there. Now here you say N is equal to the total number tumeambiwa is 850. Then we have A, B, C, D, E, F, G, H. A, B, C, E, F, G, H. Now they are all visible. Then down here now we shall have the total. We shall have the total that will go to 850. So design that way. And once you have finished up to that point, type the word finished. Type the word finished so that we proceed. Yes, Ibrahim, I can see. Yes, Sarah, see.
Finished.
Okay, thank you, Jackie. So once you have finished, then mute yourself, Jackie. The next thing that we do is to prepare equations. Is to prepare equations. Is to prepare equations. Is to prepare equations. And equations are prepared like this. The first number we are given is 316. So you say 316 is equal to 316 is those who are Nissan. So everyone who is inside the circle of Nissan, everyone who is within the circle of Nissan, it is A plus B plus C plus D. Those are the 316. Those are the 316. 316. The next one is 160. 160, it is those who are in order. So those who are in order, everyone inside that circle, we have B, C, F, G. So B plus C plus F plus G. That way. Then we have 360. 360 is those who own Toyota. So everyone who is within Toyota, C, D, E, F. C plus B plus E plus F. C plus B plus E plus F. That is everyone who is inside Toyota. Then we are told 120, they own both. So 120, they owned both Nissan and Toyota. So you come to Nissan and Toyota, where they intersect upper Ika space, we have C and D. So 120 is C plus D. C plus D. 56. 56 is members who own both Nissan and Honda. Who own both Nissan and Honda. So this Nissan and Honda, 56, that is BC. So B plus C. B plus C, that is 56. Then we have 80. Those who own Honda and Toyota. 80, it is those who owned Honda and Toyota. So Honda and Toyota, we have CF. So C plus F. C plus F. Then we are told 240 residents did not own any. So those who did not own any, they are the ones who are outside the 3 circles. That is H. So 240 is H. That is all the information that we have been given. After that, you bring in a whole equation, which we say 850 will be all of them. A plus B plus C plus D plus E plus F plus G plus H. We call it the whole equation. After you have given us the whole equation, you now begin the workings. So the workings, it is where now we seek to know the specific values of these alphabets. And the journey commences by checking whether in your equation you already have one value that you have gotten. And such one value that we have gotten is this one, H. So we have 240. So now that we have gotten this, you mark it that way. After nakibia hapa, you record 240. You record it there, 240. Then, using the latest catch, the value you have gotten last, we call it the latest catch. Using that, you check where else you can get it. And where else is here? It is together with kinahu. So kwanza unakuja, you mark and do like I'm doing. do like I'm doing. So you mark that. That means we have gotten H, or we know H. All these others, we need to know them. And in seeking to know them, we find that A, B, C, D is known. A, B, C, D is known because of this. So we still have three others that are not yet known. E, F, G. So this E, F, G, we can come here. See here, we have E, F. There. And in the E, F, we know C, D. So we will come here and argue that EF is known. EF is known. So tumebakishiwa G. So how do we get G? G will then be 850. You minus this block of A, B, C, D, which is 316. Then you minus this block of EF. Now this EF, tumeipata hapa juu, hapa kuna 360 na iko na CD, and CD is 120, so it must be 360 minus 120 here. So tumetoa this EF. Then we come and subtract H. We come and subtract H, which we know is 240. So work out that and tell me the answer. Type the answer. I want the answer from everyone. Yes, Ibrahim, I can see your answer. What about the others? Yes, Sarah. Good. So we have 54. So if it is confirmed, unakimbia hapa unaandika G is 54. And the equation which has helped us to do that is this one. You mark it out that way. You mark it out. Higher. Using the latest catch, this G, you check where else you can find it. And when you draw your eyes, you find it here. So you come here and say G is known. And it is together with BC. It is together with BC. So we can be able to get F. So F will be 160 minus BC, which is 56, minus G, which is 54. Which is 54. So give me the answer for that. Yeah, good. I can see 50. Jackie, I am not seeing anything from you. I'm sure you are also assisting us. So F is 50. So what has helped us to get that is this equation. So you mark it out that way. Then you now look for where else you can get F. And in doing so, you quickly find F here together with C. So you say here, F is known. So C then will be 80 minus F, which is 50. So give me the answer. 80 minus 50 is what? Yeah, I can see that. Good. So C is that. So Nakibia, you record it there. Then this one has helped us, you mark it out. That C, it can help us here, where we will say that B will be 56 minus 30. 56 minus 30. That is 26. So B is 26. B is 26. This is the one that has helped us. When we come here, we know C. So we'll be able to say D is equal to 120 minus C, 30. That gives us 120 minus 30. Waiting for the answer. Yes, 90. So D is 90. So nakibia hapa naweka 90. So this one has a seated. So I come here where I already know C, and I also know CD, and I know F. So this E will be given as E is equal to 360. 360 minus CD, which is 120, minus F, which is 50. Minus F, which is 50. So that gives us what? 190. So E is 190. Kuja hapa unaweka 190. Aya. From there, we got to A. So this one has also helped us. So when we come here, we realize that we know BCD. We know BCD. So if we know BCD, we'll be able to say A is 316 minus B, which is 26, minus 30, minus D, which is 90. That is 170. So you put 170 here. So after you have done that, you mark out this equation. And that tells you you have used all the equations that we had listed. And we have also gotten all the answers that you wanted. Now confirm whether if you add all these values, they go back to 850. And tell me yes or no. Ibrahim says yes. Others? Sarah, good. Okay. So if that is the case, then that is very, very good. And we now proceed. We now proceed with other solutions. So you now say other solutions. Other solutions. So we look at what the question had wanted. So this examiner had wanted we give him what? Number one, present the above information in the form of a Venn diagram. So we already have presented the Venn diagram. Number two, the number of residents who own all the three. So those who own all the three, that is Roman 2, it is C. And we know that C, it is 30. C is 30. Higher. The number of residents who own just one. So those who owned just one, it is A plus E plus G. A plus E plus G. And this is 170 plus 190 plus 54 plus 54. So tell me the answer to that. $414. 414. Good. The next question that I want us to solve together is the question that was tested in December 2021. December 2021. So go there to December 2021. Talking of December 2021, December 2021, question number 6B, which says that a global conference on the blue economy was recently held in Kenya and was attended by 280 delegates from America, Europe, and Africa. So N is 280. So this one is America. That is America. This is Africa. That's Africa. And then this is Europe. Okay, now that you have not grown, let me interchange them. maybe interchange, but there is no problem. You can put anywhere you want. But here we are beginning with Europe. This is Europe. Then it's followed by Africa. And then there is America. So know that the total down here will take us back to 280. So that after you have drawn the diagram, we do the equations. We do the equations. So once you get to that point, write the word there or finished, so that we do the equations together. Okay, we have finished. So let's get the equations now in place. So the first one, we are told 70 delegates represented Europe. So Europe is this one. So we'll say 70 is equals to A plus B plus C plus D. 70 of them. 96 represented Africa. So 96, they are coming from Africa. And Africa is B, C, F, G. So B plus F plus, or B plus C plus F plus G. The next one is 128. They represent America. 128. So those who are in America, it is C, D, E, F. So C plus D plus E plus F plus F. Then we are told 20 represented all the three. So all the three, that must be C. So 20 is C. Is C. 25 represented America and Africa. 25 equals America and Africa. So America and Africa, it is CF. So C plus F. C plus F. The next one is 22 represented America and Europe. 22 represented America and Europe. So America and Europe, it is CD. C plus D. The next one is 26. 26, they represented Europe and Africa. Europe and Africa, that is BC. So B plus C. B plus C, it is 26. So that is all the information that we are given. And I've told you after that, you draw the whole equation. And the whole equation is 280 should be equal to A plus B plus C plus D plus E plus F plus G plus H. That is the whole equation. The whole equation. From there, let's start the workings. Let us start the workings. Let us start the workings. So I have told you in doing the workings, we check whether there is a single value we have noted. So C is already provided. Christine, good afternoon and welcome. So this 20, we record here and we mark it out that. And then we check where else that can help us. So this C is present here with B. So it will help us know that B is equal to 26 minus 20. Give me the answer. 26 minus 20. Is equal to what? Is equal to 6. Good. So unakimbia unaweka hapa 6. Then you mark this one out because it has helped us. From there, we go to this one. Because we know C here, it will help us know D. So D is equal to 22 minus 20. 22 minus 20, I can see 2 already. So you put 2 there and you mark it out that. The next one is here. We know C. We know C. So when we get there, we say F is equal to 25 minus C, which is 20. That gives us 5. That gives us 5. So ukibia hapa weke 5. So this one has a secret. So if we go up here, we already know CD. We also know F. We already know CD and F. So we can be able to know E. We can be able to know E that it will be 128 minus CD, which is 22, minus F, which is 5. 128 minus 22 minus 5. I can see 101. Then we got to, this one has helped us. The next one is here. We already know BC and we also know F, those 3. So they can help us know G. So 96, that is G, is equal to 96 minus BC, which is 26, minus F, which is 5. Oh, here is not recorded 1. So tell me G is what? Yeah, the others, you are so quiet. Yeah, good, good. I need several persons to give me the answer. 65, good. So G is 65. So this one has a secret. So when I come up here, I have BCD known. So I'm looking for A. A is 70 minus B, which is 6, minus 20, minus 2. That is 42. So we put 42 there. Then we can come here looking for H. We know all this. So you say H should be 280. You minus all these others. And then you tell me the answer. H is 280, you minus all the others, then tell me the answer. $39. So if that is the case, this one has also helped us, this one also helps. So confirm whether all these they are adding to 280. Confirm whether they are adding to 280. Okay, good. So if they are adding, let's now proceed and provide the other solutions that the examiner wanted. The other solutions. So in the other solutions, they were asking Roman 2, the number of delegates who represented at 3-2. So those who represented at 3-2 continents, it is those who represented 2 or more. So it is B, C, D, F. It is B plus C plus D plus F. And this will be 6 plus 20 plus 2 plus 5 plus 5. That is 87. Then Roman 2, Roman 3. Roman 3, it is the number who represented only 1. The number who represented only 1, that is A plus G plus E. So those who presented A, they are 42, G, they are 65, and E, they are 101. Two 08. Roman 4. Roman 4 is the number who represented none. That is H. And H, we know it is 39. 8 we know it is 39. Are we okay? If you are okay, say yes. If no, you raise a concern, let me know. If you are okay, write the word okay or you write yes so that I know we are together and I proceed. Yes, Ibrahim, good. The others are waiting. If you are okay, you say yes. If you are not, you type your concern. Okay. You're taking too long, so silence will be interpreted to mean okay. Based on that, I seek to proceed. And now I want us to handle this question of September 2021, question 1A. And we are told the Aviation Perspectives Agency recently conducted a market survey to determine air travel preferences of 170 travelers. So N is 170. And they were using excellent. So this is excellent. The next one is Safari. Safari. This other one is Tumaini. Tumaini. So I would like you to do that question on your own and write the answers. Giving you 5 minutes. You solve the question fully on your own and write for me the answers. I will come to check. Where are the answers? The answers. We give you 5 more minutes. Good. I can see the answers that A is 64, B 8, 12, 16, 8, 12, 16, 41, 6, 14, and 9. That is from Ibrahim. What about the others? Are we in agreement? Sarah and Jackie, at least you were there when we began. Like Christine, who has joined late. Jackie is okay. Sarah, are we okay with that? Okay, so if we are okay, Sarah, I can't hear you, I can't see your chat. That is fine. Then on your own, I would like you to attempt. Let me give you two more that you can attempt. You can try this one of May 2019. May 2019, question 1C. May 2019, question 1C. And November 2018. November 2018, question 1C. November 2018, question 1C. So that is what I would like you to attempt. Then from there, I want us now to handle, or I did not send you the questions on the notes on probability theory. So let me send right away now so that we proceed to the next. So confirm receipt of those notes. Okay. So if we have seen them, let us now proceed to the next topic. The topic is called probability theory and distribution. Probability theory and distributions. Probability theory and distributions. That is what we need to discuss now. Probability theory and distributions. And In this discussion, we are going to go through the main items. So first of all, we need to know what is probability. Now, probability is simply a measure of chances. Is simply a measure of chances that something will happen or will not happen. That is what we call probability. It's a measure of chances. It's a measure of likelihood. It's a measure of likelihood. And therefore, it is used where we have events or we have items that have more than one possibilities. It is an environment that we call environment of uncertainty. The environment of uncertainty. And therefore, the general formula of probability, it is always given as the desired to divide by the possible, as you can see in the notes. It is the desired to divide by the possible. For example, if you toss a coin once, you can either get a head or you get a tail. You can either get a head or a tail. So if they ask you the probability of getting a head, it is head, which is desire, over the possible head, tail, that way. And then you convert these to numbers. This is 1, and these are 2, and this is 0.5. That is 0.5. So that is the probability of getting ahead. Now, in our discussions, there are some terms that we need to define. One is called trial. Now, a trial refers to an experiment. It refers to an action. And this experiment or this action must have more than one possible outcomes, and it is something that you can be able to predict, rather you can be able to repeat. For example, tossing a coin, that is a trial. Tossing a coin, that is a trial. You can see this one has more than one possible outcomes. Another example is sitting for an exam. When you sit for an exam, there are more than one possible outcomes. And all these, you cannot tell which one exactly will come out. And we are also saying you can be able to repeat. You can be able to repeat the experiment. The next thing that we need to look at is what we call the event. Now, event, we are talking of results. These are results or these are outcomes. These are results or outcomes. Like again, when you toss a coin, the result could be a head or a tail. When you sit for an exam, the result could be a pass or a fail. So those are the outcomes or the events. The other thing is what we call sample space. Sample space. Now, sample space is simply a group of outcomes. Sample space is a group of outcomes. And if you have gathered all the outcomes, that sample space is called collectively exhaustive. And the example would be if you toss a coin twice, you get a head or a head, then you get a tail or a tail, then you get a tail or a head, then you get a head or a tail. Now that one is a collectively exhaustive sample space because it has captured all the items which are required there. The next one is what we call elementary events. Now, elementary events, they are events that you cannot subdivide. You cannot be able to break them any further. That's what we call elementary events, and we have been given an example there. Then we have what we call compound events. Now, compound events, these are events that you can be able to break down. Like what we have said here, tail, tail. These two, you can separate them. So if you can be able to break them down, that is what we are calling compound events. The other one is what we call marginal probabilities. Now, marginal probabilities, they are probabilities of elementary events. They are probabilities of elementary events. Like the one we have computed there, 0.5, that is marginal probability. It is probability of one item. The next one is what we call mutually exclusive events. Mutually exclusive events. Now, these mutually exclusive events, they are events that cannot happen at the same time. They cannot happen at the same time. And these kind of events, they present what in the other topic we have called union of sets. They present the union of sets. And therefore, they are described using the word or. They're described using the word or. And therefore, we handle them using the additive rule. So, the additive rule is normally given as probability of A or B. Probability of A or B is given as probability of A plus probability of B, U minus probability of A and B. Probability of A and B. And I want to illustrate this. If you are given a set of A, if you are given a set A, or maybe let me illustrate when we are handling a question. Let me illustrate when we are handling a question. That is very, very visible. The next one is what we call independent events. Or before I talk of that, should okay. Independent events, they are down there, independent events. Now, independent events are events that can happen at the same time. They can happen at the same time. And this one, they represent what in set theory we have called intersection. They represent what we have called intersection of sets. And therefore, they are connected by the word R, A and B. And we handle them using the multiplication sign. When we are dealing with them, we use the multiplication sign. Then we have what we call compound events. Dependent events. Dependent events. Now, dependent events, they are events that for one to happen, the other one must have happened. Now, these ones, they are connected by the word given. And the word given is represented by a stroke like that. And we handle them in three ways. The first way is called contingency table. The second one is called probability tree. And the third one is called Bayesian rule. Bayesian rule. So all of those, we are going to do examples for each. Now from there, we have what we call types of probabilities. And when we talk of types of probabilities, we have what you can see there written as theoretical probability or axiomatic. Now these are probabilities that are based on opinions, that are based on emotions. These ones, they do not have any experiment that has been done. They don't have any experiment that has been done. They are just based on emotions, theories, opinions, and so on. So they are therefore not very accurate. They are therefore not very accurate when it comes to forecasting. The next one, we call them priori probabilities. Priori. These are also theoretical, but they are done or they are given by a person who is an expert in the area that they pertain to. So they are given by a person who is an expert. For example, myself, having been a teacher for long, I have observed many students who have come my way. Some have passed the exams and some have not passed the exams. And I therefore know the behavior of someone who is likely to pass and who is not likely to pass. So when I look at a person and I say, your chances are like this, now that one is priori. But if I look at the skies and I tell you there will be rain in the next 2 hours, now that is theoretical, because myself, I am not trained on matters meteorology, on matters climate. The next one, we call them empirical probabilities. Empirical probabilities. Now, the empirical, they are the ones which are based on experiments. They are based on experiments. They are based on results of experiments. They are based on results of experiments, and they are therefore more objective. Actually, these two, we call them subjective because there was no experiment, and this one, we call it objective because there was an experiment. We call them objective. Then we have what we call, I think I've discussed priori, I've discussed dependent, I've also discussed conditional or dependent. I've mentioned the Bayesian rule. We shall be using it. So I think we are going to call it a day at that point. When we meet next, we shall start handling those questions that have been given there. So thank you so much for attending. We meet in the next lesson. Dependent, Christine, I've said those are events that for one to happen, the other one must have happened. For example, for you to be listening to me, now, you must have joined my class. Those are, so joining and listening are conditional. They depend on each other. Now, I have said they will be handled using contingency tables, probability trees, and Bayesian rule. I have questions that are there for each one of these. As you can see there in the handout, we will do all of them. So I think that is okay, Christine. Good. So thank you so much. I will send the video for anyone who has not, particularly those who have joined late. And when you get to that channel, kindly subscribe to that channel. And there are also other good things in the channel that you can be able to listen to other than QA. Thank you so much.